Grand Test 7 Chemistry for JEE Main. This is your lucky sir. Given below are two statements. One is labeled as assertion and the other is reason. Okay. See, assertion is at 10 degrees Celsius, the density of a 5 molar solution of KCl is some x gram per mole. The solution is equal to minus 21 degrees Celsius, the molality of the solution. Here density is not given, only molarity is given. And what he is asking is the molality of the solution will remain unchanged. True, because generally molality is independent of temperature. So molality is not going to change. But I strongly think one line is missing here. Reason, the molality of a solution does not change with temperature as mass remains unaffected with the temperature. If you take this statement, this is absolutely right statement. So if some lines are not missing, if this is the only statement, the molality of the solution will remain unchanged and the molality does not depend on temperature because mass is unaffected. Correct explanation and correct statements. Okay, now 10 seconds every question. Matching. Done. Delta P0, delta T0, isothermal and isobaric. Delta H of reaction definition, exothermic process. Protective colloid, lyophilic. Emulsions, liquid. Positively charged colloid, negatively charged colloid. Correct? 2 seconds questions. Don't waste time here. HTSO4 plus BaO2. BaSO4 plus H2O2. Two seconds questions. BeCl2 with lithium aluminum hydride. It's good reducing agent. So it's the preparation of beryllium hydride. 2BeCl2 plus lithium aluminum hydride. 2BeH2 plus LiCl plus AlCl3. All four alkyl groups, silanes. It is something wrong. Yeah, 1 methyl, 3 OH groups. So that will go for 2D, two-dimensional, 2 OH groups chain, and this is dimeric. Dimeric means it will be like this. Ten seconds. No, 10 seconds is not 1 second. Because this question you have written so many times. Disproportionation reaction. Maximum stabilization crystal fields depends on ligand strength. Cyanide is the strongest ligand, strong field ligand, so cyanide. Two statements are mentioned here. Classical smog occurs in cool, humid climate. It's a reducing mixture of smoke, fog, and sulfur dioxide. Photochemical smog has components ozone, nitric oxide, actinium, formaldehyde, pan. Both right statements. Environmental chemistry, class level. Which of the following is a structure of separating funnel? This question, I think, it has come in past years. Practical chemistry. Ozonolysis reactions. See this, ethane 1,2 dicarbonaldehyde. Ethane 1,2 dicarbonaldehyde mentioned. Plus glyaxal. Glyaxal is CHO, CHO. What we need to do is take out these two oxygens and keep a double bond there. Okay, now. So it must be 1, 2, 3, 4, 5, 6 member ring with two double bonds alternatively. 1, 3, that's all. Cyclohexa 1, 3 diene. One is gone. Second, you see 5-hexanol. Hexanol he mentioned. Let us take this is 1, 2, 3, 4, 5 oxo. Now what you need to do is just add them, take out this oxygen and keep them double bond. So 1, 2, 3, 4, 5, a double bond, one methyl group. Fine. So option D. Good question. I think this is previous question. By seeing the question, I can say. This F group, NO2 group are not affected. This iodine is, it is secondary alkyl halide, and here carbocation is going to be stable. So this part, this is a bulky group, so it will be coming here, this will be going out. This won't come, this won't come. There is a possibility of this group also, but this is dimethyl formamide is given. Dimethyl formamide is better for SN2 reaction. So SN2 reaction, inversion takes place. Here the twist is with this DMF. Inversion means if it is R, it will be S. (46). First step, then palladium barium sulfate, Rosenmund reduction. What are the options? So many options are here. CrO3 and H2SO4. So it is acidic medium, we will go for COH. NaBH4 as ester. Ester has no effect on NaBH4. This is fine. NCRT reaction it is. In NaBH4, give me 1 second. No reaction. So A and D. Sometimes we get confusion. Hoffman degradation reaction, the migration of only an alkyl group takes place from carbonyl carbon to the amide to the nitrogen atom. So you should know the mechanism of Hoffman bromide reaction here. I will give you a Hoffman bromide reaction mechanism. This is a wrong statement. The group is migrated reaction to electron deficit. This is right. Hoffman bromide mechanism I will give you. Here it will take much time. Bakelite switches. Gliptal, PVC, styrene. Direct questions. Positive test with silver amine, that means tolerance reagent. And to show a positive test with tolerance reagent, it must be aldehyde. All these are aldehydes. With acetic anhydride, triester derivative is 3 OH groups should be there. All they have 3 OH groups. So it is also first 2.7, no sense. We don't get any idea here. Compound A produces an optically active compound and an optically inactive compound on treatment with bromine water and HNO3 respectively. See, bromine water is somewhat oxidizing. HNO3 is again oxidizing. If you are using bromine water, this part will become COH. Then these are optically active. But HNO3 if you are using, this will also become COH, optically inactive. Why optically inactive? Because there will be plane of symmetry. Very good question. Chemistry in everyday life. You need to remember this. Options, options, options. Hair conditioner, toothpaste, laundry soap, dishwash. Memory, complete memory. F is 0.930. Here I will show you how to solve this. 0.930. No? Let us take Fe plus 2 ions are X and Fe plus 3 ions are going to be 0.93 minus X. Right? Total 0.93 only. So X into, okay, now what percentage we will take? X percentage, na? Plus 2 oxidation state plus 0.93 minus X into plus 3 percentage. This is all equals to total oxidation state of iron is going to be plus 2. So how much it is? Plus 2x. This is minus 3x and this is plus 2.93 na? 79 is equal to plus 2. Minus x is equal to minus 0.79. So x is equal to 0.79. What is the percentage of x? That is plus 2. 0.79 by 0.93 into 100. Comes around, how much percentage it will be? 85. Good question actually. Easy question. Repeat regular. And what you can say? NCERT question. With uncertainty in velocity and position of a minute particle in space are the mass of the particle in grams is. Okay. Uncertainty in velocity. Mass is asking. M is equal to h by 4 pi delta x delta v. H is given 6.626 into 10 to the power of minus 34 joule second. 4 into 3.14 into delta x is given. Both these are given 2.4 into 10 to the power of minus 26, 10 to the power of minus 7. Go for simplification. If you are simplifying, you will be getting your answer 22. Two grams of a non-volatile non-electrolyte solid dissolved in 200 grams of two different solvents, A and B, whose ebullioscopic constants are in the ratio of 1:8. The elevation in boiling points A and B are in the ratio of x by y. The value of y is. Very simple. Delta TB is equals to Kb into M. See, I value is not required here, non-electrolyte. Gone. Kb values are given 1:8. So for A, if you take Kb value is 1, ebullioscopic constant. Molality will also be same because molality is equals to 2 by okay, molecular mass. Solute will be same. 200 grams of difference, that will be same. So M is going to be same. So that A delta TB is 1, B delta TB is Kb into M, that is equals to 8. So it is nothing but 1 by 8. Y is equals to 8, it is 1. Very simple question. Unnecessarily wasting time. Okay. To NOCl. In an experiment, 2 moles of NOCl was placed in 1 liter flask and the concentration of NO after equilibrium established was found to be 0.4. The equilibrium constant at 30 degrees Celsius is. See? So I would like to take out. What is the question? Here is given 2 moles in 1 liter flask means initial concentration is 2. At equilibrium, 2 minus 2x will be there and this will become 2x and this will become x. And the concentration of NO after equilibrium established was found to be 0.4. It is 0.4 is saying, so x is equal to 0.2. So this will become 1.6. So Kc is equal to 2NO 0.4 square into 0.2 by 1.6 square. Correct, na? 1 time 4 times, 1 time 4 times 1.6. Okay. So 0.2 by 16. 0.2 by 16, if you are going to make it simple, it will become 125 in 10 to the power of minus 4. 1.25 or 125 in 10 to the power of minus 4. The limiting molar conductivities are given. The limiting molar conductivity of AgA at this temperature is very simple. NaI, NaNO3, AgNO3. Go for addition. Which two we need to add? NaI, AgNO3 इन दोनों को ऐड करो. So 12.7 plus 13.3. So this is nothing but 26 minus, we need to remove this 12. So that will become 40. Kohl-Rush law. The rate constant for a first order reaction is given by the following equation. The activation energy for the reaction is given by dash kilojoules. Okay, now. What is the equation? K is equal to AE to the power of minus EA by RT. Ln K is given here. That means EA by R is equals to this one. So EA is equal to 2 into 10 to the power of 4 into R value 8.3. If you take that, the answer will come 166. The number of statements correct for the following: copper, copper 2 complexes are always paramagnetic because it contains one unpaired electron. Copper 1 complexes are generally colorless, right? Copper 1 is easily oxidized to copper plus 2. In fading solution, the active reagent is copper 1, not copper 2. So 3 are correct statements. Fading solution, copper 2 sulfate. Acidified potassium permanent solution oxidizes oxalic acid. The spin-only magnetic momentum of the manganese product formed in the above reaction, that is Mn plus 2. Mn plus 2 means 4s0 3d5. 3d5 means 5 unpaired electrons will be there. When 5 unpaired electrons are there, it is 5.9 Bohr magnetons. So you can take nearest integer 6. Two elements A and B which form 0.15 moles of A2B AB3 type of compounds if both A2B AB3 weigh equally the atomic weight of A dash times of atomic weight of B. Okay. .15 moles is equals to both are having same mass. Based on this line we need to solve. Moles of A to B is equal to moles of AB3. That means weight by 2A plus B is equal to weight by A plus 3B. So A plus 3B is equal to 2A plus B. It means 2B is equal to A. So atomic weight of A is 2 times that of B. Total number of possible stereoisomers of dimethyl cyclopentane. Dimethyl cyclopentane means we need to write cyclopentane. This is dimethyl. This is dimethyl. This is dimethyl. 3 chances are there in that number of possible stereoisomers. It cannot show anything. Here it is a chiral carbon. This is also a chiral carbon. But if they are present same side or opposite side, there will be plane of symmetry. Okay, if they are same side, cis, plane of symmetry will be there. Trans, no plane of symmetry. So trans can show optical isomers. And he is asking stereoisomers. Stereoisomers means cis and trans is also possible. So cis 1, trans 2. In this case, again plane of symmetry. Okay, plane of symmetry is possible. So cis trans is possible. And totally it should be 6. What is, but position should be given. If positions are given, it will be easy. Otherwise, we can mention 6. Okay, here 1 2, here 2 3 6. It cannot show anything. Thank you. This is your Lakshma Reddy sir. I wanted to make little different. That's why this session was very slow. Okay, na? Next time we'll go with full energy. Thank you.